In an intriguing development for astrophysics, scientists have discovered a star exhibiting behavior unlike anything previously recorded, shedding light on a new class of enigmatic celestial objects. The object, designated ASKAP J1832-0911 or ASKAP J1832 for short, has captivated astronomers with its peculiar patterns of radio and X-ray emissions, raising questions about its nature and origin. A collaborative effort between a team of astronomers utilizing NASA's Chandra X-ray Observatory and the SKA Pathfinder ASKAP radio telescope in Australia revealed that ASKAP J1832 is categorized as a long-period radio transient. First identified in 2022, this class of objects fluctuates in radio wave intensity in a regular pattern over extended periods, specifically every 44 minutes. This time frame is remarkably longer than the rapid variations observed in pulsars, which are neutron stars rotating at incredible speeds and typically emit signals multiple times per second. What makes ASKAP J1832 particularly fascinating is its dual variability. While the object cycles through changes in radio intensity, Chandra's observations have confirmed that it also varies in X-ray emissions on the same 44-minute schedule. This marks a significant first for long-period radio transients, as no prior object in this category has displayed X-ray variability. The research team, led by astronomer Ziteng Wang from Curtin University, noted additional complexities in ASKAP J1832's behavior. Over a span of 6 months, the object exhibited a dramatic decrease in both X-ray and radio emissions, a phenomenon that has yet to find a parallel within the Milky Way galaxy. The combination of the 44-minute cycle and the long-term variability is unlike anything we've seen before, Wang stated, highlighting the unique nature of this discovery. The analysis has led researchers to rule out the possibility of ASKAP J1832 being a pulsar or a neutron star interacting with a companion star, as its properties do not align with the expected signal intensities for such objects. Some characteristics of ASKAP J1832 could suggest it is a magnetar, an exceptionally magnetized neutron star, yet its age of over 500,000 years raises further questions about its bright and variable radio emissions. Interestingly, ASKAP J1832 appears to be located within a supernova remnant, which typically houses neutron stars formed during the explosion of a massive star. However, the research team asserts that this proximity is likely coincidental and that the two are not physically related. They propose that ASKAP J1832 could be an isolated white dwarf or possibly a white dwarf paired with a companion star, though this would necessitate the strongest magnetic field ever recorded for such a celestial body. This groundbreaking research has been documented in a paper published in the journal Nature, with an independent team from Tsinghua University in China also reporting their discovery of the source, albeit without the same focus on its X-ray behavior. As the astronomical community continues to analyze ASKAP J1832, the implications of these findings extend beyond mere curiosity. Understanding such objects could provide vital insights into stellar evolution, the dynamics of supernova remnants, and the underlying physics that govern these mysterious celestial phenomena. With further observations and studies on the horizon, astronomers are poised to unravel more mysteries about the universe, potentially redefining our understanding of the cosmos and its myriad wonders. As humanity ventures deeper into the cosmos, the International Space Station ISS continues to serve as a vital laboratory for understanding the complexities of space travel and its impacts on the human body. The latest activities aboard the ISS, reported by NASA, reveal an intensive focus on scientific research, equipment maintenance, and the overarching goal of preparing for future missions to the Moon and Mars. On May 28, 2025, the Expedition 73 crew engaged in critical life science studies aimed at deciphering how extended periods in microgravity affect vision and immune system function. NASA flight engineers Johnny Kim and Nicole Ayres initiated their workday with a sophisticated retinal response test that measures how astronauts' eyes react to light stimuli. This experiment is part of the CIPHER suite, which encompasses 14 human research investigations designed to safeguard the health of astronauts on long-duration missions. As Kim affixed electrodes to his forehead and around his eyes, Ayres operated the data collecting hardware. Keenly aware of the importance of maintaining optimal vision for tasks that include piloting spacecraft and conducting intricate scientific research. Such studies are foundational as NASA aims to protect future crews during extended missions to destinations like Mars, where the challenges of space travel become exponentially more complex. In parallel, Station Commander Takuya Onishi from the Japan Aerospace Exploration Agency JAXA focused on understanding the effects of spaceflight stress on cellular immunity. He processed blood samples that had been incubating in a research device, preparing to analyze them for signs of cellular stress or damage. This work underscores the critical need for reliable health monitoring systems to defend against infections in the harsh environment of space. Meanwhile, NASA flight engineer Anne McClain devoted her efforts to the maintenance of the Colbert treadmill, a vital piece of exercise equipment necessary for counteracting the muscle atrophy and bone density loss that astronauts face in microgravity. Her routine inspection involved greasing axles and cleaning components, a reminder of the meticulous upkeep required to ensure the functionality of equipment that supports crew health. Adding to the day's accomplishments, Roscosmos flight engineer Alexei Zabritsky conducted Earth observations, capturing stunning images of the Pacific Ocean and its surrounding landscapes. His colleague Kirill Peskov also completed several training sessions for the European robotic arm, which enhances operational capabilities for spacewalks and external payload handling. In a broader context, NASA recently announced the upcoming SpaceX Crew 11 mission, slated for launch no earlier than July 2025. This mission marks a significant milestone as it will involve 4 crew members from 3 different space agencies, including returning astronauts Zena Cardman and Mike Fink. Their reassignment reflects NASA's commitment to developing a robust collaborative international presence in low Earth orbit, fostering advancements in scientific research and technology. As efforts to explore deeper into space intensify, the ISS stands as an indispensable platform for testing hypotheses and preparing for the unknown challenges that lie ahead in human space exploration. With ongoing studies into the physiological effects of long-term spaceflight and the continuous maintenance of critical equipment, the crew aboard the ISS is not only safeguarding their own health but also paving the way for future missions that could one day see humanity residing on other celestial bodies. The results from these investigations will undoubtedly inform the design of spacecraft habitats and health protocols for generations of explorers to come. In a compelling intersection of science and geopolitics, retired astronaut Colonel Terry W. Virts recently reflected on his experiences aboard the International Space Station ISS during a tumultuous period in history. Speaking to Colin Post from the Kiev Independent, Virts recounted his time spent with Russian colleagues amid the backdrop of Russia's annexation of Crimea and the onset of hostilities in eastern Ukraine from 2014 to 2015. His personal anecdotes offer a unique perspective on how the realities of international relations can permeate even the most collaborative environments such as space exploration. Virts, who served as a commander on the ISS, observed a shift in the attitudes of his Russian crewmates during this politically charged time. There was a palpable change in how they reacted to the news coming from Earth, he noted. Many of them seemed to be influenced by the Russian propaganda machine, which was alarming given our shared mission in space. His comments emphasized the delicate balance between cooperation in scientific endeavors and the complexities of national allegiance, suggesting that even in the realm of space exploration, politics can weigh heavily. As Virts argues, it is crucial for missions in space to remain insulated from terrestrial conflicts. Space should be above politics, he stated, advocating for the continuation of collaborative efforts among nations regardless of their political climates. His insights are particularly resonant as discussions about the future of international cooperation in space continue, especially with the increasing militarization of space and tensions among global powers. In a separate but equally significant development, NASA recently announced the crew assignments for its upcoming SpaceX Crew 11 mission to the ISS, scheduled for launch no earlier than July 2025. This mission marks the 11th crew rotation under SpaceX's human space transportation system, showcasing the ongoing collaboration between NASA and private aerospace companies.
The Crew 11 team will consist of NASA astronauts Commander Zina Cardman and pilot Mike Fink alongside JAXA astronaut Kamiya Yui and Roscosmos cosmonaut Oleg Platonov.
This diverse team is expected to continue the ISS's legacy of scientific research and international collaboration.
NASA's commitment to advancing scientific research aboard the ISS remains strong even as the agency faces potential budget cuts and fiscal uncertainty.
The ISS has been a vital platform for testing new technologies and studying the effects of long-duration spaceflight, serving as a cornerstone of human space exploration for over 2 decades. As NASA navigates financial challenges, the ongoing partnerships with international space agencies and private companies are more important than ever. Additionally, the beauty of space exploration was brought back to Earth when NASA astronaut Nicole Ayers, currently aboard the ISS as part of the SpaceX Crew 10 mission, captured stunning footage of the aurora borealis. Her unexpected video highlights the dual role of astronauts. While they witness breathtaking phenomena, they also contribute to important scientific data that informs climate monitoring efforts. "We see beauty while scientists see data," Ayers remarked, illustrating the profound connection between art and science in the realm of space exploration. Meanwhile, at a more local level, former NASA astronaut Catherine Katie Coleman recently celebrated the planting of a NASA Artemis moon tree at Bernardston Elementary School in Massachusetts. This initiative ties back to the Apollo 14 mission, where tree seeds were taken into space and later grown on Earth. Coleman's participation underscores NASA's commitment to inspiring future generations through education and environmental stewardship. As we look ahead, the future of international collaboration in space remains uncertain yet hopeful. The voices of astronauts like Virts, Ayers, and Coleman remind us of the importance of unity in the face of global challenges. With upcoming missions and initiatives aimed at inspiring young minds, the intersection of science education and international cooperation will continue to shape the narrative of human exploration beyond our planet. As humanity continues to push the boundaries of exploration beyond our planet, the complexities and challenges of conducting scientific research in space are gaining increasing focus. Recent updates from NASA shed light on the intricacies of microgravity research, ongoing studies aboard the International Space Station (ISS), and upcoming missions that will further enhance our understanding of life beyond Earth. In a fascinating discussion led by NASA expert Emily Furfaro, the nuances of conducting experiments in microgravity were laid bare. While astronauts aboard the ISS experience a weightless environment, they still face the realities of Earth's gravitational influence, complicating many aspects of their research. For instance, Furfaro explained that the microgravity environment can make even simple tasks challenging. Items can float away, as demonstrated by a set of tomatoes that went missing for 8 months after being harvested in 2022. To mitigate such issues, researchers employ various methods, including enclosed spaces for experiments and the strategic use of Velcro to secure equipment. Bubbles in liquids present another unique challenge. Unlike on Earth, where bubbles rise due to gravity, they can interfere with measurements and microfluidics in space. Therefore, specialized equipment is designed to manage these bubbles, ensuring that research remains unaffected. Furthermore, the lack of convection in microgravity means that maintaining proper air circulation for experimental organisms is critical. This sometimes necessitates the integration of fans into habitats or strategic placement of experiments in high-traffic areas of the ISS to benefit from natural air movement caused by astronaut activity. The importance of careful experiment design cannot be overstated. Every research initiative on the ISS involves a dedicated team of scientists who spend years preparing and refining their methods for success in this harsh and unconventional setting. As Furfaro succinctly put it, the answer to how we do research in microgravity is with a lot of practice and preparation. Meanwhile, life aboard the ISS continues to be a blend of rigorous scientific inquiry and essential maintenance. Recent updates from NASA highlighted Expedition 73, where astronauts focused on studying the effects of long-term space habitation on ice structure and cellular immunity. These investigations are key to understanding how extended exposure to microgravity can alter human physiology, crucial knowledge as we prepare for longer missions to the Moon and Mars. NASA astronauts Johnny Kim and Nicole Ayres conducted tests to evaluate the electrical responses of the retina to light stimuli, an essential part of understanding potential vision changes in space. As they collected biological samples and maintained vital equipment, they contributed to a broader mission of safeguarding astronaut health during extended spaceflight. Looking ahead, NASA is preparing for its SpaceX Crew 11 mission, set to launch no earlier than July 2025. This mission represents a continuation of the agency's long-term collaboration with SpaceX and will see 4 crew members from 3 different space agencies living and working aboard the ISS. Commander Ziteng Wang and pilot Mike Fink of NASA, along with JAXA astronaut Kamiya Yui and Roscosmos cosmonaut Oleg Platonov, will join the existing crew as they engage in scientific expeditions that will enhance our understanding of life in space. As NASA continues to navigate the challenges of space exploration, the agency remains committed to advancing scientific research that not only informs future missions but also enriches our understanding of life on Earth. The ongoing development of training programs such as the STAR spaceflight technology applications and research course underscores this commitment by preparing researchers for the unique demands of conducting experiments in the novel environment of space. In conclusion, as humanity stands on the brink of a new era of exploration, the insights gleaned from ongoing research in microgravity will be instrumental in shaping the future of space travel. With a focus on meticulous preparation, innovative solutions, and collaborative efforts, NASA and its partners are poised to unlock the mysteries of life beyond our planet, paving the way for ambitious missions to the Moon, Mars, and beyond. In a significant moment for space exploration, a panel of leading journalists will engage in a lively discussion about NASA's ambitious plans for deep space exploration, including the long-anticipated journey to Mars. Scheduled for May 29, 2025 at 3 p.m. Eastern Daylight Time, the live-stream event will feature prominent reporters from notable publications including Christian Davenport from The Washington Post, Loren Grush from Bloomberg, and Joey Roulette from Reuters. Eric Berger, senior space editor at Ars Technica, will moderate the conversation. The debate comes at a time of uncertainty surrounding NASA's future under the leadership of the newly appointed administrator Jared Isaacman, who has garnered attention through his connections to SpaceX and the ongoing complexities of public-private partnerships in space. As Berger notes, the community of professional space reporters is fairly small, and these individuals possess a wealth of insights about what is really going on. Key topics of discussion will include the feasibility of human missions to Mars in the near future, the impact of Elon Musk's business interests on NASA's policies, and the agency's transparency in the political climate of a potential second Trump administration. Simultaneously, NASA faces internal challenges as the Trump administration's Department of Government Efficiency, helmed by Musk, has announced the closure of the Goddard Institute for Space Studies (GISS) in New York City. Established in 1966, GISS has been pivotal in climate research and planetary science, contributing to significant projects like the Voyager missions and the development of the theory of plate tectonics. The decision to shutter the institute has drawn sharp criticism from the scientific community, with Matt Briggs, president of NASA's largest union, calling it an attack on NASA. Critics argue that the closure is unlikely to yield meaningful cost savings while jeopardizing decades of valuable research. Briggs emphasized the nonsensical nature of the budget cuts, stating, "It makes no fiscal sense whatsoever." As GISS employees prepare for relocation, the legacy of the institute hangs in the balance, with its historical contributions to science at risk of being lost in transition. The union plans to petition Congress to secure funding for GISS as they strive to protect the institute's future. In the midst of these controversies, NASA continues to capture the imagination of the public. Recently, the Curiosity rover provided a breathtaking panoramic view of the Martian landscape from Mount Sharp, showcasing the stunning geological features of Gale Crater. This imagery not only highlights the breathtaking beauty of Mars but also underscores the scientific value of ongoing exploration efforts. As NASA stated, you can imagine the quiet thin wind or maybe even the waves of a long-gone lake lapping an ancient shore. Another significant development includes Sierra Space's recent contract award from NASA for lunar logistics. This contract signifies a step towards the agency's goal of sustainable lunar exploration, further emphasizing the ongoing evolution of partnerships within the aerospace industry. As NASA navigates these multifaceted challenges and opportunities, the upcoming discussion promises to offer critical insights into the agency's trajectory, with the potential for groundbreaking missions on the horizon. The future of space exploration remains a topic of both excitement and scrutiny as the world watches closely to see how these developments unfold. In an era defined by ambitious strides in space exploration, recent developments highlight both the technological advancements and the ethical dilemmas that accompany humanity's quest beyond Earth. With NASA recently awarding a lunar logistics contract to Sierra Space, the stage is set for a new chapter in lunar exploration. This contract is part of NASA's broader Artemis program, which aims to return humans to the Moon and establish a sustainable presence there by the end of the decade. Sierra Space, a company specializing in space infrastructure, is expected to play a pivotal role in supporting these ambitious goals. While the Artemis program heralds a new age of lunar exploration, preparations are underway at the Luna Analog Facility in Germany, where astronauts are engaging in simulated moonwalks. This state-of-the-art facility, developed by the European Space Agency ESA and the German Aerospace Center DLR, allows astronauts to rehearse crucial tasks including photography in a safe but realistic lunar environment. The facility's simulated surface presents unique challenges akin to those anticipated on the Moon, such as limited bandwidth and the interference of lunar dust on equipment. ESA officials have emphasized that the objective of these simulations is not to create false representations of lunar conditions but to refine techniques for capturing high-quality imagery in the harsh lunar environment. This exercise was not about creating fake moon footage, they stated. Instead, the focus lies on developing effective compression technologies to enhance the quality of video transmission back to Earth. As Fox Schiffner, a representative from DLR, articulated, these efforts should help agencies and companies create a ground truth for video applications and equipment. As preparations ramp up, the challenge of transmitting high-definition video from the Moon remains a critical focus. Historically, the Apollo mission struggled with low-quality footage due to the limitations of the technology at the time. Today, with advancements like the handheld Universal Lunar Camera (HULC) being developed specifically for lunar missions, the potential for capturing stunning lunar imagery is within reach. However, challenges such as signal delays and the need for lightweight, energy-efficient communication equipment continue to pose significant hurdles. In broader discussions of extraterrestrial exploration, the ethical implications of potentially introducing Earth life to other celestial bodies have gained traction. Researchers including astrobiologist Charles Cockle have proposed the controversial notion of inoculating moons like Saturn's Enceladus with Earth microbes to study how life might develop in alien environments. Enceladus, with its subsurface ocean and the elements necessary for life, presents a compelling target for such experiments. However, the ethical considerations are profound. There is a risk of disrupting any existing ecosystems should they exist. The idea of injecting life into another world evokes comparisons to historical incidents on Earth where introduced species wreaked havoc on native ecosystems. Morgan Cable, a NASA planetary scientist, voices concerns about the feasibility and morality of such endeavors, stressing the importance of ensuring that any target world is indeed uninhabited before proceeding. We have very sensitive instruments, but I don't think they are significantly sensitive now to make the declaration that a world is not inhabited, she notes. As discussions around inoculation and lunar exploration progress, the implications extend beyond mere scientific inquiry. They touch on fundamental questions about humanity's role in the universe and the responsibilities that come with our expanding reach into the cosmos. The outcomes of these explorations could provide invaluable insights not only into our own origins but also into the potential for life in environments previously deemed inhospitable.
Looking ahead, the convergence of advanced technology and ethical discourse will undoubtedly shape the future of space exploration.
With NASA's Artemis program and the increasing interest in moons like Enceladus, humanity stands on the brink of a new frontier. The coming years will likely witness not only the return of humans to the moon but also the unfolding of profound discussions about our place in the universe and the legacy we choose to leave as we reach for the stars.